Hello there, greetings from Xerxez IT Training and Projects. So in this video I'm going to explain or demonstrate the 5th machine learning lab program. This is going to be beneficial for the students who are studying under the Vishweshwara VTU University. So I think in my previous videos already I have covered the four algorithms, that is finds algorithm, you take candidate elimination algorithm, ID3 algorithm, even artificial neural network, the program I have explained. So in this video I'm going to explain the 5th program, that is related to naïve based classifier. So as far as syllabus is concerned, there are two programs related to naïve based classifier. One is for numerical data and another one is for the textual data. So in this session I'm going to explain how to calculate the accuracy using, or how to execute the naïve based classifier by using some sample the data set. Okay, so what I'm going to do is, already the data set is available in the book. Okay, the syllabus copy, same data set I'm going to use and will try to predict the accuracy. In next session or maybe next upcoming videos, I'll try to explain okay how to use or execute naïve based classifier for textual data. Okay, anyways, so this is the program. So let me try to copy the name of the program. Okay, so write a program to implement naïve based classifier for a sample training data set to store as a CSV. So to execute this program, okay, so I'll use the Jupyter notebook. So I hope you are already familiar with the Jupyter notebook. So what I have done here is, already I have created one folder. Okay, inside that folder already I have uploaded the data set called play a tennis. Let's try to have a look on the data. Okay, so as far as the data is concerned, okay, so this is the ready-made data already available in the book: outlook, temperature, humidity, wind and play. Okay, same data set we have used even for ID3 algorithm also. Same data set I'm going to use for the next naïve Bayesian classifier for numerical data. But for the simplicity, what I have done, okay, I have removed the day column as well as I have removed the feature column, this one. So I'm concerned only about this data. Okay, so as far as, since we need numerical data, so that's the reason I have done. Next, what I have done, so I have replaced all these values. Let's say sunny, okay, with 0, overcast I have replaced with 1, and rain I have replaced with the 2. In the same way I have done it for done for hot also. I have replaced hot with a 0 and mild with 1, cool with the 2. Similarly, high and normal, strong and weak with the 0 and strong with the 1. Understood? Just for the simplicity purpose I have done it. Okay, and in programs, since this fall under the category of categorical data, so you can use the label encoding technique, okay, in the programs to do that one. But for the better understanding purpose, what I have done, so manually I have replace all those categorical type of data into zeros and 1. In the same way, if you take my target, that is nothing but the play, so we have binary format of data, that is no and yes. I have replaced no with a 0 and 1 with the yes value. Okay, so I'll explain that one in Jupyter notebook. So after converting the entire file, okay, with the extension .csv, I have uploaded in my Jupyter notebook project folder. Have a look on this. So next is, let's try to create one Jupyter notebook, okay, to execute this numerical type of a data. Okay, so this may take little time, okay, to open it. So once after that, we'll try to execute the complete naïve based classifier using naïve based classifier for the respective data set. Hold on. Well, so this is the main dashboard of my Jupyter notebook. So same I'm going to use to execute the project. Okay, the nav base classifier. So let me try to change the name of this file first. Hold on. So let's try to change the name of the file first. So just hover over to that untitled page. Okay then. Okay, right now we are in the Jupyter notebook. So let me try to rename the file name. So okay, so let's try to give naïve base classifier for numerical data. Okay, numerical data. So you can keep the name. Better you try to keep the name. You try to use some short forms here. Okay, just to avoid the lengthy file name. So next is after the successful renaming that one. Now that it's time. So first, it's time to upload all the libraries which are required to execute this naïve base the classifier. Okay, but remember already I have uploaded my data which is in the form of play underscore tennis dot csv. Okay, so let's try to import some of the fundamental libraries which are required to execute this program. Obviously we need pandas spd. Next we need import numpy to handle numeric numbers. We need numpy np. Next for the visualization, what I will do, I'll try to use two libraries. Okay, so usually I use cborn. Okay, cborn as sns is an alias of the cborn. In the same way matplotlib, okay, for the visualization purpose I use matplotlib dot py plot and have the alias as pld. Okay, fine. So after the successful installation, or let's say after uploading all the libraries, it's time to fetch the data from the backend in the sense in the same folder. Since my file is available in the same folder, so I'm going to fetch the same file. Okay, I'll try to fetch the same the file from the same folder. Okay, let's try to have one variable. Let's say naïve. Okay, naïve is equal to, since if you want to fetch the data, generally what I do, I used to take the help of pandas, read csv. Okay, read csv. So next straight away give the name of that particular csv file. Just go to your folder, copy the name of the csv file, okay, which is nothing but the play 10s. Next paste it over here. Okay, paste it over here. So I'll try my level best to keep the program as short as possible, because I don't want to increase the number of lines in this program. Okay, so that you can easily understand and execute during exam time. So obviously I don't want the index here. Okay, so just to eliminate the index, to remove the index, I'll try to call the function called index column and give the index name array name. Okay, array the position, that is nothing but the 0 here. In the same way, just to change the format, okay, I'll try to use parse date. Okay, parse date also I'll use. Next you try to have the index as a 0 here. Okay, so next it will take time. Let's see. Okay, since my system is heavily loaded, so maybe this will take little time. Okay, to fetch the data from the file. There is an error here, read underscore csv is not working. What is the problem? Play tennis.csv. okay, here csv play underscore tennis dot nav dot pd dot read underscore csv play tennis index column. Next parse, it should be dates. Okay, it should be dates. Okay, parse dates, shift and enter it. So it got executed. Okay, fine, good. So next is, it's time to check the like how the data look like. Since I have already explained, I have already converted the entire categorical type of data, category type of a data into zeros and one. Let's try to see okay how the data look like here. So I'm going to use head will display the first records here. So already it has displayed. Since I'm removing the index, okay, by default the index is not there, so this is going to be my first feature, which is nothing but the outlook. Next is going to be the temperature, next will be the so temperature, next will be the humidity, and next will be the wind here. Understood? So I'll keep the data as it is. Okay, so if you want, you can give the labels also here. Okay, since this head will display 5 record in the same way, if you want to check the entire record, so you can type that variable name called the knife. Okay, so it will display all the 14 days of the record. Okay, so next is after the successful uploading the data. Okay, now next is, if you want, you can go for the feature engineering also. Say knife shape. Okay, so now it will display us the total number of records which are present, as well as the total number of columns which are available in this data set. Understood? Now it's time to separate the data in the sense to have your dependent and independent the variables here. So as far as 1.1, 1.2, 1.3 is concerned, they are independent variable, nothing but your X data. Understood? Features. So based upon those independent variable, we are going to predict the target function, nothing but here. So play tennis, whether the Aldo is able to play the tennis or the not. Understood? So now next is, so what I will do, same process I'm going to execute here. That means nothing but I'm going to separate my the X value as well as the Y value. Okay, but before that one, let's try to separate. Okay, let's try to display how many the columns are there, so that it will be easy for me to separate my X and the Y value once you have the information of the index. Okay, to have the information of your index, what you can do is call your variable name. Okay, so next is straight away call columns. It's pretty simple. Python is very simple. You can execute your program just in 15 minutes. Okay, so since it has displayed my the columns, since I have very small amount of data here, so we need not to worry much about the data, and missing values are not there. Okay, so all those stuffs can be avoided. Next is, okay, I need to store this one in my X variable. Let's try to have one X variable. So I'll call knife, which is nothing but the variable name knife, and I'll try to use log function. Okay, LOC function, and I'm going to fetch all the records. I want all the records of the columns, okay, from here to here, from 1.1, 1.2, okay, 1.3. Okay, so let me try to copy the entire thing, so that next I can delete that the target function, which is nothing but my 0 of value. Okay, so next is, hold on, let me try to arrange this. So done, so far so good. Next is shift and enter it. Perfect. So that means I have separated the X value. If you want to check the X value, what you can do is call that X, which is in the capital letter. Again, use the method called the head. Okay, it will display all the X values. Perfect. So I got all the records 1, 1.2, 1.3, 1.2 as well as the 1.3 as well. Understood? Next, in the same way, I need the Y value also. Okay, to display the Y value, so what I will do, again I'll try to take Y equals to knife. Knife is obviously my variable over there. Now I will use ilog function, okay, just to give the position of the target value here. So since the target value in the location third, okay, so I want all the records of the column called third. Understood? Third is nothing but the 0, 1, 2, 3. Okay, third is nothing but the target a function over there. Okay, so now next is shift and enter it. Yes, perfect, it got executed. Now my complete data set I have divided into X and the Y value. If you want to check, you can check using a head function. Okay, so Y dot head function. Perfect, it got I have all the target functions in my Y value. Understood? Now next is we can check the correlations also. How the features are correlated with each other. Okay, so that's the reason I have used SNS, Seaborn, okay, and PLT map, libraries, okay, to check the how the features are correlated with each other. Okay, so PLT, so I'll call an alias called PLT, figure show. Okay, figure is a function if you want to draw a figure in Python. So next, give the figure size, how much you want to give the size of the figure. Right now I'll try to keep the figure size be 18, okay, in height as well as the width wise. Next is, once the size of the figure is after setting the size of the figure, you call SNS. Under SNS we have an option called heat map. So I'll try to take the help of the heat map, okay, to check the correlation between the features, okay, of that particular data set. Okay, so naïve core method I will use, okay, to have the correlation, and annotations obviously I'll try to keep, I need the annotations, so I'll keep a true here. So next is color. Okay, so color of the map, C map you can use, and I'll use red, to red, next yellow. Okay, so let's try to have yellow. Okay, next the green goes for 1, red goes for 0 here. Next, straight away just try to display the graph using PLT show message. So show, shift and enter it, shift and enter it, it executing. Let's see how the graph look like. Hold on. Yeah, I got the graph. Okay, so beautiful graph. So I can correlate now. So as far as what I have done here is, if we analyze the graph, okay, so I have done in X and Y axis, I have kept all the features. Even I have the target functions also. I'm not concerned about the target function. But if you check here, 1.2 and 1.1, okay, is highly correlated. It gives me high accuracy, that is nothing but the 52%. Okay, so I can 52% of my accuracy. Okay, so I can fetch from this two data, that is 1.1 and 1.2. In the same way, if you compare that 139 also, that is 1.2 and 1.3, I guess. Yeah, it's it's 0. Okay, so it's targeted function it gives. But if you compare this one 1.2 and 1.1, it gives me nearly 52% of whatever the accuracy I'm going to get here. So I got some information, okay, how our data is highly correlated with each other. So either I can choose, okay, so if you take this, obviously I'm going to it 0.52 with those two features. Let's see what those features are. So obviously there is nothing but the outlook and the temperature. Okay, so based upon this one I can decide whether the Aldo is able to play the tennis game or not using naïve pace classifier. Hope you are cleared with this. Next, okay, it's time to run the algorithm. Okay, since already my data is clean now, and as well as I have divided my data into X and the Y value. Understood? So next is what I will do. X and Y value we have, obviously we need to split the values. So to split the value, I'll try to take the help of sklearn. Okay, take sklearn dot model. Okay, so under model we have selection. Okay, selection, call selection, import train test split, train underscore test underscore split. Okay, test underscore split. Perfect. So next is, let me try to run this. Yeah, it is executing now. So obviously that line of code will execute. Next is, it's time to split the value in terms of X train and X test. Even we are going to do it same thing. I'm going to do it for Y value also. X train, okay, and X test. Using training data, I'm going to design my model. So once the model is ready, so next what I will do, I'll try to pass the test data. Okay, and always remember, okay, keep the flow of this x train, x test, y train, y test, okay, in same format, y train, otherwise you will get an error message. Okay, so x train, x test, y train, y test. Next you call that method called train underscore test underscore split. Okay, split. Next is split. Next, obviously pass your x data, nothing but the feature, y data, nothing but your target function, and try to assign the percentage of the training data, how much you want to pass it for testing. Okay, so as far as test is concerned, I'm going to take 20% of this data. Okay, that is nothing but 0.2 for testing, and rest 80% I'm going to use it for training the model. Okay, so training the model. So done, shift and enter it. Okay, it got executed, perfect. There are no error message. Next is it's time to call our naïve based classifier. Naïve based classifier works on P of h of d is equal to P of d of h into P of h divided by P of d. P of d should be consistent, okay, nothing but the 1. So if it is consistent, directly we can calculate the probability using posterior probability using P of h of d is equal to P of d of h into P of h. Okay, so we have Gaussian NB system. I'm going to use Gaussian NB system to execute this. Sklearn dot naïve, under naïve we have naïve base, we have Gaussian system, Gaussian NB system. So import Gaussian NB. Okay, Gaussian ka always remember G should be capital here. Okay, Gaussian NB, Gaussian, yeah, NB. Fine, done. So once it got executed, that means I can run the x and test data. Now next what I will do, I'll just try to create one variable, let's say GNB, Gaussian NB, okay, or you can have naïve based classifier also. So call this method, okay, so call this algorithm as a method inside your test data. So as in GNB, so that means I'm going to store this, whatever the Gaussian NB algorithm is there, functions are there, say parameter, I'm going to access through GNB now. Okay, so first and foremost we need to check whether my data set matches or fit with my the model or not. Okay, so to do that, GNB, there is an option called fit. So use fit to fit the data, okay, the training data with the algorithm, that is nothing but the Gaussian NB. Obviously it is going to use it is going to calculate on the probability basis, it is going to calculate the accuracy. So obviously I want to pass my x of train as well as I have to pass my y of train data. Okay, so pass y x of train as well as y of train data and to my yeah, perfect. Now see, that means my training data fits with my algorithm called Gaussian NB. So obviously I can calculate the accuracy. To predict the accuracy, next what I will do, I'll try to use one variable called y of predict. Okay, so next is GNB. GNB is nothing but the variable where I have my Gaussian NB, okay, to calculate the probability using naïve Bayesian classifier. There is a method called predict. Okay, call predict, next to pass your testing data. So x of test data I will pass now. So since my model is ready, now I'm going to pass my test data. Okay, so pass it, shift and enter it. So that means my final result, it store where in y of predict now. Understood? Now I have to check the accuracy. To check the accuracy, I'm going to use okay, matrix system, Sklearn. Again I will use Sklearn. Okay, import matrix. Okay, import matrix. Typing mistake, hold on. Import matrix. Matrix. Yes, perfect. Import, there is a typo mistake here. Import, okay, so I have to remove O here. Fine. So shift and enter it. So that means my matrix is ready. Now I can check, okay, the accuracy score of this data set using Bayesian, the classifier. Okay, so I'll use print statement to print the accuracy. Okay, so just I want to display, okay, accuracy. Okay, so now next is call that method called matrix. Under matrix I have accuracy score. So use accuracy, okay, underscore score method to display the amount of accuracy of the model. So next is pass your y test data, y test. Okay, so y test data, so that was remaining y test data, and you pass y predicted data, and y predicted data is will be having your the x test data. Let's try to run now. Let's see how much accuracy I'm going to get. Shift and enter it. Yes, perfect. I got 33% of the accuracy, okay, which is not good enough. We need to modify. Maybe I should go for hypertuning systems here. But the problem here is we have low data also, that can be a problem. Okay, so what I will do, so testing, whatever the testing I have done here is, let's try to increase this one for 3 test data, 30% I'll use. So let's try to execute again. Let's see whether I'll get some good accuracy, okay, of in 70% of the training data. Shift and enter it. Again shift and enter it. So execute all the cells. Okay, let's see whether I'm going to get any changes after, okay, changing the training and testing data here. So I got 75, that's perfect. 75% is perfect. Okay, so I got it using 70% of the data I have used it for my training, and 30% I'm using for okay, the testing purpose. I hope you are clear. Practice this program. Okay, in next session I'm going to discuss about the same naïve based classifier for text data. Okay, so there I'm going to use vectorization technique and tokenization technique, okay, to convert your the text data into numerical data. Thank you for watching, and please subscribe my channel for upcoming the videos. We are planning to have a separate playlist for Julia programming language as well as the RPA using UiPath. Thank you.